Okay, let's dive in. We've got some really fascinating material today sitting right at this, intersection of cutting-edge tech and, well, huge questions about reality itself.
Yeah, absolutely. You sent over these notes and articles about Google's newest quantum computing chip. Willow, they're calling it.
That's the one, Willow. And it seems like its announcement immediately stirred up this, really old debate about whether our universe is the only one.
It's a great link, isn't it? We're going from a very concrete piece of engineering, this powerful new chip, straight into some seriously deep physics and philosophy.
So that's the plan today. We'll unpack the tech itself, what makes it so powerful.
Right, the quantum mechanics behind it. And then explore why some folks, like the lead at Google, think this points towards parallel universes.
We definitely need to look at the counter-arguments, too, the critiques of that idea.
Definitely. And then maybe zoom out a bit to the broader multiverse concept scientists are kicking around, kind of separate from the computing angle.
Exactly. Connect the tech leap to these really mind-bending ideas. Should be some aha moments, I think, because this stuff really challenges how you think things work.
Let's start with the tech then. Google's Willow chip. We heard about Sycamore a few years back, its predecessor. How big a jump are we talking about here?
Well, Sycamore had, 53 qubits? Maybe later 70?
Yeah, around that. Willow, though, boasts 105 qubits.
Mm-hmm.
And the key thing for you listening isn't just, oh, it's more qubits.
Right, it's not linear.
Not at all. With quantum computers, the power grows exponentially. Adding just one qubit basically doubles the computational space you can explore. So going from, say, 70 to 105, that's a massive, massive increase in potential.
And you see that in the headline number they reported. Willow apparently solved some specific tricky problem in under 5 minutes.
Okay.
And the estimate for how long the best classical supercomputers we have today would take, 10 septillion years.
10 septillion. That's a one with, what, 25 zeros?
Yeah. It's basically an incomprehensible amount of time.
It really drives home just how different these machines are. Classical computers use bits, right? 0 or 1. Simple.
But quantum computers use qubits, and their magic comes from a couple of core quantum principles.
First one being superposition.
Yeah, superposition. So a qubit isn't stuck being just a 0 or just a 1. It can be both at the same time in a sort of fuzzy probabilistic state.
Exactly. Until you measure it, that is. Then it settles. And the second big one is entanglement.
The spooky action at a distance, as Einstein called it.
That's the one. Where two or more qubits get linked, their fates become intertwined no matter how far apart they are. Measure one, you instantly know the state of the other, instantly.
Spooky is right. Okay, so how do superposition and entanglement create this insane speed advantage?
Well, think about it. If your qubits can be in multiple states at once, thanks to superposition, and they can influence each other instantly over distance, thanks to entanglement, then the computer isn't just crunching numbers one after another like your laptop. It can explore this huge landscape of possibilities all at once.
So it's processing tons of potential answers simultaneously.
That's the essence of it. Massive parallelism. The whole system represents and manipulates this incredibly complex state, exploring options in a way classical machines just fundamentally can't.
And that ability, exploring so many states at once, is what immediately kicked up this really fascinating and, pretty controversial debate.
Right from the top, too. The head of the Google quantum team, Hartmut Neven, actually came out and suggested something provocative.
What was that?
He basically said that Willow's performance, and quantum computing generally, might actually support the idea that the computation is happening across many parallel universes.
Okay. So drawing directly on the many worlds interpretation of quantum mechanics.
Exactly. And the sources point out this isn't totally out of the blue in quantum computing circles. David Deutsch, the Oxford physicist, floated a similar idea years ago.
He suggested their power comes from tapping into resources in other realities.
Kind of. Deutsch's argument was sort of like, if this computer is evaluating countless outcomes simultaneously, where is all that happening? His hypothesis was, maybe it's happening in this vast computational space spread across all these potential parallel worlds.
So each qubit state could, in theory, exist in a different universe, and the computer somehow uses all of them.
That's the gist of his interpretation. The power comes from accessing or combining results from this potentially infinite resource pool across realities. It's a wild thought.
It really is, almost sci-fi. But as you'd expect, and as the sources highlight, not everyone buys that leap from the math to literal other worlds.
No, definitely not. Ethan Siegel, the astrophysicist and science writer, pushed back pretty strongly against Nevin's claim.
What's his take?
Siegel argues that Nevin is basically confusing the mathematical framework of quantum mechanics, the equations physicists use to describe all possible states, called Hilbert space, with the physical existence of those states as separate universes.
Ah, okay. So the math allows for all these possibilities and helps us build the computer.
Right.
But that doesn't automatically mean each possibility is its own physical reality somewhere else.
Precisely. Siegel's view is more like quantum mechanics has these inherent weird properties or probabilities, complex states within our universe, and quantum computers are just incredibly clever ways of harnessing those properties here, not borrowing power from other dimensions.
It's a more grounded interpretation, maybe, but still acknowledging the physics?
Yeah, exactly. A different interpretation of the same physics. And it's important to stress, even critics like Siegel are absolutely blown away by the technical feat Google achieved. Building a machine that can control and utilize these complex quantum states is incredible, regardless of why you think it works.
So whether Willow is tapping the multiverse or just mastering quantum rules here at home, it's pushing boundaries. And it naturally leads us from this specific debate into the broader ideas about the multiverse that scientists are exploring anyway.
Totally. Because the idea that maybe our universe isn't the only one. It pops up in cosmology and theoretical physics too, often for different reasons than quantum computing. Like this idea that our universe might just be a tiny piece of something much bigger.
Like a bubble or a membrane.
Yeah, maybe like a thin film on the edge of a bubble expanding into some higher dimension. It comes partly from trying to grapple with the sheer scale of what we can see.
And just reminding ourselves of that scale is pretty humbling. The observable universe, what is it, tens of billions of light years across, a light year being nearly 6 trillion miles.
It's vast. And the sources remind us it's packed with maybe 200 billion to 2 trillion galaxies, each with hundreds of billions of stars.
Makes you feel tiny. And our little solar system is way out in the suburbs of the Milky Way galaxy.
Yep, orbiting the center at something like 500,000 miles per hour. But it still takes us, 230 million years to go around once?
Just incredible scales. And thinking about that immensity is partly what fueled the multiverse idea, right? This fine-tuning problem.
Exactly. That's a big one in cosmology. The observation that the fundamental constants and laws of physics in our universe seem, well, almost perfectly dialed in.
Dialed in for what?
For things like stars to form, for atoms to be stable, for complex chemistry, and ultimately for life as we know it to exist. If you tweak things like gravity's strength or the electron's mass, just a tiny bit, poof, the universe would look completely different, likely lifeless.
So the argument is, it seems too lucky, too improbable for it all to line up perfectly just by chance in the only universe there is.
That's the thinking for some physicists. It leads to the hypothesis. Maybe it's not just luck. Maybe there are countless other universes where the constants are different, all sorts of random values.
Oh, we just happen to live in one of the universes where the conditions allowed for us to evolve and observe it.
That's the multiverse solution to the fine-tuning problem. It suggests all possible variations get realized somewhere in this enormous ensemble of universes. We're just in a habitable one.
And do these broader multiverse ideas connect back to quantum mechanics at all, beyond the computing debate?
Some do, theoretically, like Heisenberg's uncertainty principle, that fundamental fuzziness and unpredictability at the quantum level.
Yeah.
In some interpretations, like the many worlds view we mentioned, every time a quantum measurement could have multiple outcomes, reality actually splits. A whole new universe branches off for each possibility.
Constantly creating new universes.
Potentially, yeah. And another connection, maybe even more speculative, comes from quantum field theory, these virtual particles that pop in and out of existence in empty space. Some theories wonder if similar fluctuations, but on a huge cosmic scale, could actually inflate and spawn entirely new bubble universes from the quantum foam.
Wow. Which leads to these even more recent theoretical models you mentioned, like string theory and brain cosmology.
Right, where our universe might be a three-dimensional brain, like a membrane floating in a higher dimensional space, often called the bulk.
And there could be other brains, other universes floating nearby.
That's the idea. Like sheets of paper drifting parallel to each other in a larger room. Different universes existing on different membranes.
And some theories even speculate that if two of these brains collided,
the energy release could be immense.
Yeah.
Potentially enough to trigger something like our own Big Bang, creating a new universe or radically altering the ones that collided.
Yeah, it really does stretch your brain trying to visualize this stuff. Higher dimensions, colliding universes.
It absolutely does. It really highlights the limits of our everyday intuition and perception. But that's kind of the point of theoretical physics, right?
Yeah.
Using math to explore realms beyond what we can directly see or easily imagine.
Okay, so we've gone way out there into the theoretical cosmos. Let's pull it back for a second to the here and now. Google's chip. Regardless of whether it's borrowing power from other universes or not, this kind of quantum computing has real potential, right?
Oh, absolutely. Forget the multiverse debate for a moment. The practical promise of quantum computing is enormous. This tech could genuinely revolutionize whole industries.
How so? What kind of problems could it tackle?
Problems that are just too complex for even our best current supercomputers. The sources mention things like drug discovery, being able to accurately simulate how molecules interact. That could speed up finding new medicines dramatically.
Okay, that's huge. What else?
Designing new materials from the ground up. Think super efficient catalysts, better batteries for electric cars, or grid storage.
Right, crucial for sustainability.
Exactly. Or optimizing incredibly complex systems, like managing power grids, or even maybe modeling things like fusion reactors more effectively.
And Google, despite the, exciting speculation from folks like Nevin, they seem focused on the practical side too, emphasizing the science.
Yeah, the sources suggest Google is pretty careful about emphasizing transparency, scientific rigor, validating the actual computational results they can prove here in our reality.
Which makes sense. But still, you can't help but ponder the bigger questions this raises, can you?
Not at all. Even if the multiverse connection is just speculation for now, the sheer power of these machines forces us to think. If quantum computing does somehow hint at other realities, what does that mean for our understanding of reality itself?
Yeah, like how do you wrap your head around the idea that maybe other versions of you in parallel worlds are unknowingly contributing to solving a complex problem that benefits this world?
It's deeply strange. And if you take the broader multiverse theories seriously, the idea that every possible version of reality, every choice, every outcome exists somewhere.
What does that do to ideas like identity or destiny if infinite versions of you exist, making every possible choice?
These are ancient philosophical questions suddenly getting poked by cutting-edge technology. It shows how science and philosophy are still deeply linked.
It really does. It's a testament to, human curiosity, our drive to build these incredible tools and then immediately use them to ask the biggest possible questions about the universe, or maybe universes.
Even when we know our perspective is probably limited, going from a tiny chip to infinite possibilities.
So, yeah, we kicked off with this amazing piece of Google's Willow chip breaking computational records.
Yeah, that's staggering speed.
And that speed immediately plugged us into this huge ongoing debate, scientific and philosophical, about the multiverse. Are there other realities out there?
And we saw how quantum mechanics, with its really weird rules like superposition and entanglement, is kind of the common thread. It's what makes the computers powerful, and it's what underlies some of the theories about multiple worlds.
We looked at the specific arguments for and against using quantum computing as evidence for parallel universes.
Hearing from people like Nevin and Deutsch on one side, and Siegel offering that important critique on the other.
And then we broadened out, exploring why physicists think about multiverses anyway, ideas like fine-tuning or quantum fluctuations spawning new universes, or these wild brain world scenarios.
Right, these bigger cosmic ideas.
But ultimately, Google's achievement itself is just. It's a marvel of ingenuity. It shows what we can build and calculate right here, pushing the limits within our reality.
Well, at the same time, yeah, it forces us to confront those ancient questions about whether our reality is the whole story.
So here's a final thought to leave you with. If the incredible power of these quantum machines does, as some suggest, hint at calculations somehow happening across different realities, does that change how you think about insight? Or creativity? Where do our good ideas or solutions actually come from? Something to ponder.